as a software developer, as a person in tech in general, you're a problem solver. So someone comes to you and says, hey, this is the issue that I'm dealt with, we need a solution. And it's your job as a software developer to design a program that solves that problem. So if you're going into retail and the retail person says, I need a program that goes on my computer that tells me how do I customize my inventory in the background when I'm selling products to other persons. How do I make sure the amount that I'm selling I have enough of and I don't have to go back and put all that stuff in. Web development. Web development says, hey, you know, we've moved into this age of technology where everybody needs a website and they want to know what my business is about, and I want it to reach masses of people, but I'm only here based in a small town and I really want to reach the world with my product. That's where web development comes in. System architecture, this is like your bridge between hardware and software. A lot of people are based specifically in software, but hardware also plays a big deal in that. How do we maximize the performance of this while still making this device as light as possible? Systems architecture is pretty much the interface, the guts and the insides of the computer. Data analysis, because we're in an area of technology, there's constant data coming in all the time. Anytime you click something on Facebook, anytime you like something on Facebook, anytime you Google something, all of that data is coming back into the computer. For the most part, all of that information is stored in like a really big database called the database of affinity. The database of affinity is the concept of all the things that all the people in the world like, that's all stored in one area. That means anytime you Google a pair of shoes and you get back on Facebook and now those ads are now populated to the shoes that you just looked at, all of that information is being fed back to you. So the person responsible for data analysis lets you know that, hey, if this is what's going on, right? This is the stuff that you're looking at. This is how you gather the attention of the person who's using the computer at this point in time. This is the stuff that they're interested in. This is how you market it to them. All the information is coming back in and out. Data analysis is that one person whose job it is to feed through all of this information and send reports to the people that need it. Program manager is the person who's identifying what best practices are and how does this align with what we do as a company and whether or not we're the best fit for you. Technology consulting is pretty similar in the sense that you're not necessarily doing the work, you're identifying the product that best helps them solve whatever that problem is. There's also gaming, user interface or user experience is UI or UX. These are the people who design what that looks like visually for you. So if you're good with Photoshop or creating visual representations of how things are supposed to work, you can get into UI or UX. This particular diagram shows you all the different areas in technology that are in highest demand. At the top of the list, you have software developers and applications. Everything is on your phone now, everything's mobile, everything is on a computer. We want to know, how do we reach the people all the time? Computer programmers, these are the people who ensure that your computer does what it's supposed to do. Computer systems analysis, we talked about that. That was all the data that's coming in. For any computer system that you're working with, any groups of computers, any networks of computers, they all have a constant stream of information that's coming in and coming out. And we want to know what all this information that's coming in and coming out means. How do we use the information that we're receiving in this moment to benefit our company? What does this information mean, and how do we use it and make it beneficial to us? Network and computer systems administrators, they give the rights and privileges to each member of your company in accordance with their job. If you're working on X, then you get all the privileges you need necessarily work to X, and if you need to work on A, then you need to go see somebody before you just start touching stuff in A because you don't have access to A. These are the people who lock down your computers so that you only have access to the stuff that you're supposed to access. Computer architects, we talked about this. These are your hardware and software people. They create an environment where you understand that the computer as a whole, from the hardware to the software and everything in between, the whole structure and the architecture of that computer. Web developers is a growing field, and everybody wants a website nowadays. In that particular field, you have the people who create it and then the people who maintain it. There's also software developers, quality assurance in tech, to the different, these all require a bachelor's degree, but IT is such a lucrative field in itself that literally coming out of high school, minimum $45K, and then each year you get like a 6% increase on that salary. Computer systems analysis, which are those people who process information, and starting ballpark technology is all about problem solving, innovation. And $65K, the computer programmer's starting salary, $74.5 to $75K. Information security analyst, $86,000. Computer network architects, $91K. So some of the highest paid degrees coming out of undergrad. Professionalism tips, because as long as you have a passion for technology, you walk in the room and you have to have confidence, right? Technology is in a constant state of change, right? So everyone's always looking for the next greatest thing. What's new? What's changing? What are the problems? How do we fix it? What haven't we done in technology that we can do in the future? Problem solving. Anytime you're dealing with anything in technology, it's because you were solving a problem. It's all about asking questions. Because technology changes so often, you might not always have the answers. But it's important that you're talking in constant communication with the people that you work with, or just people from different areas, and you're asking questions. And you're taking that information and you're going back and you're learning from it. And you're in a constant state of learning.